You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we examine the concepts of scalability and multi-user environments, which are critical to understanding how modern IT systems function and evolve. Scalability refers to a system's ability to grow in capacity, while multi-user environments describe setups that support access by more than one user at the same time. These two ideas go hand in hand. As more users access a system, it must scale to handle the increased load. This episode will guide you through these concepts, aligning each with the Information Technology Fundamentals Plus exam requirements. These topics appear in Domain 5 of the Information Technology Fundamentals Plus exam, specifically under data storage and database functionality. You may encounter questions that present user scenarios, such as a company expanding its operations or multiple employees accessing a database simultaneously. The exam does not expect you to design these systems, but you are expected to recognize their purpose, components, and associated terms. Understanding the role of scalability and multi-user access prepares you for success on these types of questions. Scalability is defined as a system's ability to grow in size, performance, or capacity. In technical terms, a scalable system is one that can handle increasing workloads without needing a complete redesign. This growth can involve adding more users, processing more transactions, or managing more data. There are two primary types of scalability. Vertical scalability means upgrading the hardware or software of a single system, such as adding memory or a faster processor. Horizontal scalability means adding more systems or servers to distribute the load. Scalability matters in IT because without it, systems become slow, unreliable, or unusable as demand increases. As more users connect to an application or as data grows, systems that lack scalability begin to show performance issues. These can include delayed responses, timeouts, or even system crashes. Scalable systems help ensure that organizations can grow without interruption. They also reduce the risk of downtime, improve the user experience, and lower the cost of managing unexpected spikes in traffic or data volume. Scalable databases have specific characteristics that support growing demands. These databases can expand to include more tables, handle larger volumes of records, and process queries quickly even under heavy load. Many scalable databases support distributed systems, where data and processing are shared across multiple servers. This approach helps balance the load and avoid bottlenecks. Some databases are also designed to work within cloud platforms, which offer elasticity, the ability to automatically allocate more resources as needed. A multi-user environment is a system or application that supports access by more than one person at the same time. Examples include shared databases, enterprise file systems, and collaborative editing platforms. These systems must be designed to manage simultaneous activity without compromising performance or data accuracy. Multi-user environments are essential in business and institutional settings, where different departments or team members need access to the same information concurrently. Databases support multi-user access through the use of roles and permissions. Each user is assigned specific rights, such as the ability to read, write, update, or delete records. These permissions help prevent unauthorized access and ensure that users only see or modify data relevant to their role. Additionally, systems use concurrency control mechanisms like locking or version control to prevent conflicts. For example, if two users attempt to edit the same record at the same time, the system may lock the record to prevent data loss. There are several challenges unique to multi-user environments. One common issue is simultaneous editing, where users attempt to change the same data at once. Without proper controls, this can lead to overwriting, lost updates, or inconsistent records. Performance may also degrade when too many users access the system simultaneously, especially if it is not designed to scale. Ensuring security, data consistency, and operational efficiency requires thoughtful system design and management practices. Multi-user systems appear in many forms. A cloud-based document editing platform like an online word processor allows several users to write or comment on a file in real time. In a retail setting, multiple registers might access a centralized inventory database to check stock or process sales. In a company's human resources system, several employees might update their personal information while managers review payroll data. These environments require stable infrastructure and clear access control policies to function properly. When designed correctly, multi-user database access provides significant benefits. It enables real-time collaboration across teams, departments, or geographic regions. It centralizes data, reducing duplication and improving consistency. It also allows for more efficient operations because users can work simultaneously without waiting for exclusive access. Centralized shared access also simplifies maintenance, backup, and reporting because all data resides in a unified system rather than scattered copies. The exam may use certain terms to describe these systems and their components. You should be familiar with words like scalability, multi-user, performance, and access control. Other related terms include load, which refers to the number of active users or transactions, and permissions, which describe what actions users are allowed to take. Shared resources is another important term that refers to systems, files, or databases accessed by multiple users at once. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A key element of any multi-user environment is authentication and permissions. Before accessing shared data or services, users must identify themselves, usually by logging in with a username and password. This process ensures that only authorized individuals gain access to sensitive information or critical systems. Once authenticated, permissions determine what each user can do. Some users may be allowed to only view data, while others may be able to add, modify, or delete records. The Information Technology Fundamentals Plus exam may refer to this setup as role-based access. In shared systems, roles define the boundaries of what users are allowed to do. Common roles include administrator, who has full control over the system, contributor, who can make changes to content, and read-only users, who can view data but not change it. These roles help maintain order in the system by limiting unnecessary or risky actions. For example, a financial analyst may have access to view payroll data, but only the payroll manager may have permission to modify it. These distinctions reduce errors and help preserve data security. Concurrency control is another critical function in multi-user databases. It prevents multiple users from overwriting each other's work when they access the same data simultaneously. Without this control, two users editing the same record at the same time could cause data corruption or unexpected results. Systems use locking to restrict access to data that is being edited or versioning to keep track of changes and resolve conflicts later. These methods ensure that data remains accurate and consistent even in high-traffic environments. Scalability is especially important in cloud-based systems. Cloud platforms are designed to scale resources dynamically, adding computing power, memory, or storage as demand increases. This elasticity allows applications to grow smoothly during busy times, such as product launches or seasonal spikes, and contract during slower periods to save costs. This dynamic scalability is one reason why many businesses rely on cloud services to host their databases and applications. It provides flexibility without requiring manual infrastructure upgrades. In contrast, non-scalable systems have serious limitations. As more users or data are added, the system may slow down, become unstable, or even crash. This is often seen in older systems or those built without growth in mind. These systems may experience increased error rates, lost data, or security vulnerabilities. They are also harder to maintain or upgrade since any change requires careful planning or downtime. These limitations highlight the importance of designing systems with scalability From the beginning, the Information Technology Fundamentals Plus exam may present scalability as a scenario. For example, a question might describe a company growing from 50 users to 500 and ask what feature supports that growth. The correct answer would reference scalability. Other questions may include terms like flexibility, performance, or support as clues. When you see references to system expansion or increased user activity, think about how scalability applies in that context. The exam will not ask you to configure systems, install software, or assign user roles. There is no requirement to understand system provisioning or architecture diagrams. Instead, the focus is entirely on recognizing concepts. You may be given a real-world scenario and asked whether it describes a scalable system or a multi-user environment. The goal is to identify the terms and their meanings, not to carry out technical tasks or system design steps. Scalability and multi-user environments support many core IT roles. System administrators rely on these concepts when planning infrastructure upgrades or managing user access. Database administrators use scalability features to ensure reliable performance under heavy workloads. Network engineers and cloud architects use these principles to design systems that can grow and adapt. Even support staff benefit from understanding how multi-user systems work when troubleshooting access issues or performance problems. These concepts are also foundational in areas like cloud computing, enterprise software, and software-as-a-service platforms. Whether working in networking, data analytics, application development, or security, understanding how systems scale and support multiple users is crucial. It enables professionals to build and maintain environments that are efficient, secure, and ready for growth. That's why the Information Technology Fundamentals Plus exam includes these ideas as part of its core curriculum. To reinforce the key takeaways, remember that scalability allows a system to grow with increasing demand, whether in users, data volume, or processing needs. A scalable system remains reliable and efficient even under pressure. Multi-user systems, on the other hand, allow multiple individuals to access and interact with the same system at the same time. These systems require access controls, role definitions, and concurrency management to function properly. Together, these concepts support the design and operation of modern business-critical systems. In summary, scalable systems are designed to grow without losing performance, while multi-user environments enable shared access to systems and data. Both are essential in today's IT landscape and appear across many different roles and technologies. On the Information Technology Fundamentals Plus exam, you are expected to recognize these concepts, understand their purpose, and identify their features when described in scenarios. Mastering these topics helps ensure success in Domain 5 and builds a foundation for further IT learning. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.